Hi friends, in this lecture we start unit number first, chapter first from paper number 40, that is crystal structure. Okay, first we see definition of crystallography. The study of geometric forms and other physical properties of crystalline solids by using X-ray diffraction, electron diffraction, etc. gives the science of crystallography. What is the definition of crystallography? The study of geometric forms and other physical properties of a crystalline solid by X-ray diffraction, neutron diffraction, electron diffraction, etc. gives the science of crystallography. First we see about crystalline and non-crystalline solids. What is meant by crystalline solids and non-crystalline solids? Or these non-crystalline solids are also known as amorphous solids. Okay, in the form of powder. Okay, the matter generally exists in the form of solid and fluid state. Matters are exist in the form of solid and fluid state. Further, the fluid state is divided into two types, that is liquid state and gaseous state. Okay, fluid state is divided into two types, that is liquid and gaseous state. The solids are divided into two types. Baga, matter exists in the form of two forms, that is solid and fluid state. Fluid state is divided into two types, that is liquid and gaseous state. And solid is divided into two types, that is crystalline solids and non-crystalline, or which is known as amorphous solids. We see the difference between crystalline solids and amorphous solids. Okay, त्याच्यावर शॉर्ट नोट असायची, ही काय असायची पूर्वी शॉर्ट नोट. यावेळी तुमचं मल्टिपल चॉईस आहे. बघा, क्रिस्टलाइन सॉलिड्स. In crystalline solids, there is a regular and periodic arrangement of atoms or molecules. In crystalline solid, there is a regular and periodic arrangement of atoms or molecules. But at the same time, in amorphous solids, powder form, that is a random arrangement of atoms or molecules. Okay? In amorphous solids, there is a random arrangement of atoms or molecules. Second property of crystalline solid, they are anisotropic. They are anisotropic. What is meant by anisotropic? They have different physical properties in different directions. Crystalline solids have different physical properties in different directions. Therefore, they are known as, or they are anisotropic. For example, electrical conductivity, thermal conductivity, refractive index, etc. are the examples of anisotropic solids. So in amorphous solid, they are isotropic. Amorphous solids are isotropic. That is, what is meant by isotropic? They have their physical properties same in all directions. Isotropic means have same physical properties in all directions. Okay, amorphous solids are isotropic, that is have same properties in all directions. Crystalline solids are anisotropic, that is they have different properties in different directions. Examples are nothing but electrical conductivity, thermal conductivity, refractive indices. Third property of crystalline solid, cooling curve for them breaks because of crystallization. Cooling curve of crystalline solids breaks because of crystallization. But in case of amorphous solids, cooling curve is smooth. Cooling curve is smooth. Fourth property, melting point of crystalline solid is very sharp. आपल्याला माहित आहे क्रिस्टलाइन सॉलिडचा मेल्टिंग पॉइंट काय असतो, शार्प असतो. परंतु इन केस ऑफ पावडर, दॅट इज amorphous solids, MP is not sharp. Melting point is not sharp. Fifth property, crystalline process is slow. क्रिस्टल ग्रो व्हायला वेळ लागतो. दॅट इज growth process is slow in crystalline solids and growth process is very quick in amorphous solids. This is the main difference between, that is crystalline solids and amorphous solids. Okay, also in crystals there is well developed symmetry in all crystals. There is well developed symmetry in all crystals. In every crystal there is periodic array of atoms. In every crystal there is periodic array of atoms. Crystals are formed when substance changes from one state to another state. That is in phase transformation. When phase transformation takes place, then crystals are formed. Okay, the phase transformation takes place through the process of sublimation, which is called as crystallization. The process of sublimation, that is phase transformation, takes place through the process of sublimation, which is known as crystallization. Multiple choice का लक्षात ठेवायचं. As the crystal is formed, the atoms or molecules are bonded by different bonds, chemical bonds, are nothing but covalent bond, ionic bond, metallic bond, hydrogen bond, and van der Waals bond. Okay, now we see some features of the crystals. When crystal is formed, then it has some features and are nothing but phases formed. Edges and interfacial angles are the features of the crystal. First we see about phases. The crystals are bounded by a number of perfectly flat surfaces. Surface असते माहित आहे तुम्हाला. The crystals are bounded by a number of perfectly flat surfaces which are called as faces of the crystal. Okay, the faces of the crystal may be like or unlike, सारखी किंवा different, प्रत्येक फेस वेगळा. The faces of the crystal may be like or unlike faces. The like faces, examples, cube. Cubeच्या सगळ्या बाजू सारख्या असतात. The like faces are of cube, alum, and unlike faces are of galena. Okay, unlike faces, गॅलेनाच्या फेसेस कशा आहेत, अनलाईक आहेत, आणि क्यूब किंवा ॲलमच्या फेसेस कशा आहेत, लाईक फेसेस आहेत. ओके, the second form, the crystals with like faces are in simple form. मल्टिपल चॉईसला लक्षात ठेवायचं. The crystals with like faces are in simple form and the crystals with unlike faces are in the combination form. Okay, crystals with unlike faces are in combination form. Then third feature, edges and interfacial angles. Okay, हे महत्वाचं आहे, आपल्याला पुढे लागणार आहे. Edges and interfacial angles. The intersection of two adjacent faces of the crystal forms the edge of the crystal. काय म्हणतो बघा, the intersection of two adjacent faces of the crystal form the edge of the crystal. आपण प्रिझमची वगैरे एज बघतो, दोन सरफेस मिळून एज तयार होते. Okay, this can be shown here in this page. This face, combination of two faces form a edge of the crystal. Edge of the crystal. Okay, and this is nothing but interfacial angle. This is nothing but interfacial angle. बघा, the intersection of two adjacent faces of the crystal forms the edge of the crystal. The angle between any two faces, किंवा अमधला काय is known as the interfacial angle. The angle between any two faces of the crystal is termed as the interfacial angle. The relation between plane faces, straight edges, and interfacial angles is given by, that is F plus C equal to E plus 2. F plus C equal to E plus 2, where F is nothing but number of faces, C is nothing but number of angles, interfacial angles, and E is nothing but number of edges. Formula काय, the relation between plane faces, straight edges, and interfacial angles is given by F plus C equal to E plus 2. F is nothing but number of faces, C is nothing but number of angles, and E is nothing but number of straight edges. Okay, then we see next point, space lattice. Okay, short definition आहे सुरुवातीला. Now we see space lattice. बघा, crystal माहित आहे तुम्हाला, crystal structure, regular and periodic arrangement of atoms or molecules in three-dimensional gives crystal structure, actual crystal structure. Okay, बघा, space lattice, the regular and periodic three-dimensional arrangement of atoms or molecules is called as crystal structure. Okay, this periodicity varies in different directions. the points in space about which these atoms are located, such points in space are called as lattice points. The points in space about which these atoms are located, then such points in space are called as lattice points. Then the regular and periodic arrangement of these lattice points in space is called as lattice or crystal lattice or space lattice. The regular and periodic arrangement of lattice points in space is called as space lattice or crystal lattice, or simply lattice. A regular and periodic arrangement of atoms or molecules in space is called as space lattice. If all the atoms at the lattice points, are identical, then the lattice is called as Bravais lattice. Right? If all the atoms at the lattice points are identical, then the lattice is called as Bravais lattice. Okay? Separate point है आपल्याला Bravais lattice. Okay? Lattices, Bravais lattices. Then we see about next point, that is the basis and the crystal structure. The basis and the crystal structure. We see about first basis. A unit assembly of lattice point atoms or molecules is called as basis. कसा आहे बघा basis? A unit assembly of lattice point atoms or molecules is called as the basis. It can be shown in the following figure. बघा हा basis, हा पूर्ण काय आहे basis, that is basis associated with lattice point. हा lattice point आणि हे दोन काय atoms or molecules आणि हा lattice point आणि हा पूर्ण काय basis. And this regular and periodic arrangement of basis form actual crystal structure. बघा the unit assembly of lattice point atoms or molecules is called as the basis. Then the periodic arrangement of bases in all directions gives the actual crystal structure as shown in the figure below. Crystal structure equal to lattice point plus basis. Basis कसा है? Unit assembly of two or more atoms or molecules with lattice point. Okay? This actual crystal structure can be shown by, that is lattice point plus basis. Repetition of basis in all directions. Regular and periodic arrangement of basis. Okay? Then we see about unit cell. Then next point, unit cell. What is meant by unit cell? The crystal is periodic array of bases. Crystal or crystal structure is the periodic array of bases in 3 dimensions. Therefore, this basis is called as unit cell of the crystal. एक unit cell. एक unit cell crystal ची. Okay? The unit cell of the crystal is the fundamental unit, like a brick. The unit cell of the crystal is the fundamental unit, like a brick, which consists of a group of atoms or molecules, etc. And a repetition of this unit cell at regular intervals in 3 dimensions to form a crystalline solid. Okay? The formation of unit cells like A, B, C, D, A dash, B dash, C dash, D dash, A double dash, B double dash, C double dash, D double dash, etc. with size A and B can be shown here. Okay? And lattice point ion or atom. पहिली युनिट सेल कुठे दाखवली आपल्याला? या ठिकाणी A, B, C आणि D. A, B, इथं C आणि D. दुसरी A dash, B dash, C dash, D dash. तिसरी A double dash, B double dash, C double dash, D double dash. ओके? दोन बाजू, ही A बाजू, ही B बाजू मधला अँगल आहे इंटरफेशियल अँगल दाखवला आहे. ओके? हे काय आहे? आयन और एटम हा lattice point. Then last point we see primitive or simple cell. The parallelopipeds formed by lattice points only at their corners are called as primitive or simple cells. काय? Primitive किंवा simple cell multiple choice ला लक्षात ठेवा. The parallelopipeds formed by the lattice points only at their corners are followed as primitive or simple cells. Such